we're going to run a multi-factor regression. The factors we're going to use are the return of the market minus the risk-free, so that's capital R here, and you can see this is market minus the risk-free, that's the data. A portfolio of small stocks minus a portfolio of big stocks, which is also referred to as the small stock premium or SMB, and then that's that data, and the value stock premium, a portfolio of high book-to-market stocks minus a portfolio of low book-to-market stocks, and that's HML. And I'm going to run this for a mutual fund whose symbol is FCAGX, and we'll talk a little bit about that as well. And note that I'm running the risk premia on the risk premium of the market, and then small minus big. So this is the regression I'm going to run, but I'm going to run two regressions. The first thing I'm going to run is the CAPM regression, so just the return of the portfolio on the return of the market. Next, I'll run the return of the portfolio on the return of all three, the Fama French three-factor model, and then we'll analyze the results. So first thing I'm going to do is go to data analysis, regression, and I'm going to run a single factor regression. The regression I'm going to run is going to be the return of the stock on just the return of the market, and really it's not the return, it's the risk premium. And I have labels, and my output is going to be in this cell right here. Click OK, and it runs the regression. And then the next thing I'm going to do is come down here, and I'm going to run the same, I'm going to run another regression, but this time I'm going to run it on the three factors, and then we'll take a look at the difference. So data analysis, regression, and now to run a multi-factor regression, all I need to do is make sure the data is parallel to the rest of the data, and that the rows are all equal to the same time period. And then I just highlight all three columns, labels, my output range, I don't want to overwrite the old data, I want to put it there, click OK, and now I have my three-factor regression. I can format it very quickly, the values that I need, and we can just go through this and talk about what we need. Okay. The first thing I want to talk about is, well, I'm going to go to the next tab where I have all this done and I already have it formatted. So let me just go to the next tab. It's the same numbers, but already formatted, and that's the best way to look at this. So let's look at the CAPM regression. And the CAPM regression is just the regression against the market. And the first thing I'm going to look at is the R squared, which is 72.78%. And this tells me that 72% of the variation of this mutual fund's return is explained by variation in the market return. The next thing I want to look at is the intercept, the alpha, and that's this value right here. This is what I've estimated, the alpha. And I can see that it's 0.0002, but I have a p-value that's almost 1. The p-value is 96. And remember the way to interpret the p-value. This is the likelihood of observing this value if it really is 0. And because the standard error is so large and the coefficient estimate is so small and the t-stat is relatively small, then I would say that there is a 96% chance of observing this if it really is 0. Therefore, I cannot conclude that it's not 0, and so there is no alpha here. But I can conclude with greater than 99% confidence that the market does affect the returns of this, and here is the CAPM beta. Now let's move to the multi-factor regression. And the multi-factor regression, notice that I have the R squared and now I have the adjusted R squared. Remember, the R squared measures the model's fit, but if I add more variables to the model, then the fit can't get worse, it can only get better. And so the adjusted R squared accounts for the fact that I might just be adding random things. And so even though the R squared gets larger, the adjusted R squared only gets larger if the added variable improves the fit by more than what we would expect if it were completely random. And so the rule is that if I have just a single factor model, a single regressor on the right-hand side, then I use the R squared. But if I have a multi-factor model, I want to use the adjusted R squared. And so I would conclude that 77% of the variation of this mutual fund is explained by variation of my three factors: the market, the small stock premium, and the value stock premium. Next, let's look at my coefficients. And now I have four coefficients. I have an alpha, I have a beta for the market, I have a beta for the small stock portfolio, and I have a beta for the value stock portfolio. And let's just be careful about the notation. Because I've labeled this SMB, Excel just throws this label here. So this isn't SMB, this is actually the beta of SMB. So these three values are actually my beta values. This is the beta for the market, this is the beta for SMB, and this is the beta for HML. And what I want to look at is the coefficients and the p-values. First, we can look at the intercept again, the alpha, and we can see that it is not statistically significantly different from 0. So because the p-value is so large, there's an 85% chance of observing this if it really is 0, so we can't reject the null. Next is the market coefficient. And we refer to this now as the market beta. We wouldn't call it the CAPM beta, and that's a little confusing because in a single factor regression, this is the market beta, but it's also the CAPM beta. Here, because I have multiple factors, I don't refer to this as the CAPM beta anymore, I just call it the market beta. But I can see it is statistically significantly different from 0. Now, SMB is positive and significant. It's significant because this is less than 0.05. Positive means that when the small stock premium is positive, if this beta is positive, it makes this bigger. And so that means that this portfolio, FCAGX, has a positive factor load on the small stock portfolio. When small stocks do better than large stocks, when this number is positive and this number is positive, this gets bigger. And so therefore this portfolio is very likely a small stock portfolio. Next, we'll look at the value stock beta. And so the value stock premium is negative and also significant. And it's significant because this is less than 0.05. And so there's a 99% chance that this is not equal to 0. Therefore, we would conclude that it's statistically significantly different from 0. This is negative and significant. Okay, let me think about what that means. If it's negative and significant, that means that when HML is a positive number, meaning value stocks are more than growth stocks, this is negative, that makes R smaller. And when this is negative, that makes R bigger. And so therefore, this portfolio earns more because the beta is negative when value stocks do worse and growth stocks do better. And so therefore, I would conclude that this is likely a growth stock portfolio. And so again, I see that the market beta is positive and significant. I see that the small stock beta is positive and significant, therefore this is likely a portfolio of small stocks, and I see the value stock beta is negative and significant, therefore this is likely a growth stock portfolio. And let's just take a quick look. So let me Google this fund. It's FCAGX, and I'll hit enter, and I can see that this is the Fidelity Advisor Small Cap Growth Fund and Class A. And we'll talk about the difference in mutual fund share classes later on, but the point is that this is a small cap growth fund, and this is what we found from our regression. Identifying the fund's style, i.e. small growth, is important because now it allows us to assign a benchmark to this fund. And so we can use this to figure out the proper benchmark for computing the tracking error and information ratio and classifying the fund. But we can also use this to assess whether or not there is risk-adjusted excess return by looking at this alpha, and we conclude that there is no positive risk-adjusted excess return. Okay, we'll talk about some of the other things we can do with this model results in a second.